Hey guys, so I'm going to work some problems from your first exam to get some preparation for studying for the final exam. So this is number 4, and it's asking you to use nodal analysis to find the power absorbed or supplied by the 4-volt source. So the first thing to do is to look at this problem, and you need to write as many equations as you have unknowns. And so you can see in this schematic that you already know that this node right here is 4 volts. So you really just have to come up with, you really just have 2 unknowns. We'll call that one V1, we'll call that guy V2. So I'm going to use the long way to solve it the first time, and then I'll show you the quick way to solve it the second time. So because we have 2 unknowns, we are going to write 2 different equations. And the other thing to note that's really important is that you have a supernode here. So this guy that I'm highlighting right here, this is a supernode. And so what we do as a supernode is we write an internal constraint equation for it, and then we also write an equation that sums all the currents going in and out of the supernode. So if we do that, you'll quickly see that V1 minus V2 is equal to 12 volts. And then for the sum of all the currents going in and out of the supernode, we'll write that out real quick, and that's just going to be V1 over 1K. And that's for this guy right here. So V1 is really, this is 0 right here. So we're really saying V1 minus 0 over 1K. And that's right there. So moving on, we can also say that V1 minus that 4-volt source over 1K. And that's assuming the current's going in this direction. Then for the other side, we'll say V2 divided by 1K. And I'm just dropping the minus 0 here, but technically what we're saying is V2 minus 0. So that's the current going in that direction. And then next and last is we'll say V2 minus that 4-volt source, and that's divided by 1K. And according to old Kirchhoff, that should all be equal to 0. So we can simplify this a little bit, and you'll quickly see that we have 2V2, and then we have 2V1. I don't know why I just wrote that backwards, but you get it. And then minus 8 is equal to 0. Simplify that, and we'll just say 2V1 plus 2V2 is equal to 8. So if we wanted to write this in a matrix, we can do this. It's just a simple 2 by 2 matrix. So we'll name this V1 column, V2 column. We're going to have a 1 right there and a minus 1 right there. And remember, we're going to invert this, and then we're going to multiply it by the constants, which in this case would be a 12. And then for the second equation, we have a 2 and a 2 and then an 8. And so if you throw that in MATLAB or use your calculator to solve that, you should get something like, let me check MATLAB, get like an 8 and a minus 4. So this gives us a lot of insight into the circuit, because basically what we're saying is that we're saying that right here, this is equal to 8, and this is equal to minus 4. All right, so we want to know how much power is either supplied or absorbed, we don't know yet, by this 4-volt source. And you can kind of already just guess what it's going to be, but we'll do it the slow way. So we can write some more equations here to kind of describe this. So if we go again, now that we know what the current is, we know where the voltages are. We know that the current going right here and here is going to be 8 for V1 minus 4 for that 4-volt divided by, we'll call this I1. Or we can call it I12 because it's going from 1 to 2. So we know it's 8 minus 4 divided by 1K. and that is equal to I12, and that should be equal to, you guessed it, 4 milliamps. So right now we know 4 milliamps is going in this direction. Alright, so let's do the same thing for the other side. So we'll say V2 minus 4 volts divided by 1K should be equal to, and we'll say this current right here is equal to, we'll call it I 2 to 1, the opposite. So we'll say I 2 to 1 is equal to, and so now V2 is minus 4, and we know there's a minus 4, so minus that positive 4. That's also divided by 1K. And then if we simplify that, we get minus 8 milliamps. So now you know I21 going towards that is minus 8. So really what it's telling us is that our current is going in the reverse. If you think about it, I21 is really going like that. So if there's 4 milliamps going into this, through this branch, and there's 8 going in that direction, then you know that if there's 4 here and 8 there, then this 4 volt source has to be supplying 4 milliamps. So to finish up, we know that power is equal to your current times your voltage. So since we know that the current supplied by the 4 volt source is indeed 4 milliamps, and we multiply that with 4 volts, that gives us 16 milliwatts. And that is supplied. And we know it's supplied because it's basically pushing that 4 milliamps out of it. If the direction of the 4 milliamps was going in the opposite direction, if it was going down, then we would know it was absorbing it.